All right, we're looking at 21 through 28 in the Taylor series multiple choice worksheet. So 21, for x between -1 and 1, we have our rule of series here that represents f of x. So to find f prime, notice that we can just zero in on the variable here, x to the 2n minus 1. So it looks like we can just go through and find the derivative going through power rule. So going through power rule, we can bring the exponent down, so that's 2n minus 1, and then subtract 1 from the exponent, so 2n minus 1 minus 1 will be 2n minus 2, and so this represents the derivative of the x to the 2n minus 1, and then the 2n minus 1, -1 to n plus 1, those do not get affected by the derivative procedure, so that stays as -1 to the n plus 1 over 2n minus 1. The 2n minus 1 will cancel out, leaving us with just x to the 2n minus 2, and then with -1 to the n plus 1 out in front, so that's answer choice A. Okay. Number 22, coefficient of x cubed in the Taylor series for e to the 3x. Now, we can build the e to the x from what we know, 1 plus x squared over 2 factorial, x cubed over 3 factorial. E to the 3x, we just have to replace each of the x's with 3x, so 3x gets replaced for x, gets replaced for the x squared, and then the x gets replaced with 3x here. And then if we simplify this, we get 27. If we want to find the coefficient of x cubed, we know we'll have to deal with this term here. So we get 27x cubed over 6. So 27 over 6 is 9/2, so 9/2 is our coefficient. 23, we have 1/3 raised to the I. And we know that this is in the form of a geometric series. Our ratio is 1/3. 1/3 is less than 1, so we know we can find our sum. So to find our sum is the first term divided by 1 minus 1, divided by 1 minus r, a sub 1. So if we plug n in for the I, we know the first term will be 1/3 to the n, so that's the first term. The ratio is 1/3, so 1/3 to the n over 1 minus 1/3. And if we reduce this, it becomes 2/3. Flip the 2/3 up, we get 3/2 times 1/3 to the n will be the sum. So answer choice C. Okay, 24. Which of the following series will converge? So series converge, we can look for, see if we can identify the rules to apply for this. So for the first one here, 1 over 2n plus 1, we see that this is an alternating series, so as long as this expression, this rule of sequence, goes to 0 as limit approaches infinity, and it does, so we know this series will converge. Second one here, we see that 3/2 to the n, this is in the form of a geometric series. 3/2 is greater than 1, so we know the series will diverge, since absolute value of 3/2 is greater than 1. And then for the third one here, 1 over n ln of n, this is most likely in the form of allowing us to go through integral test. So we can find the limit as b approaches infinity from 2 to b of 1 over x ln x, go through u substitution. We let the u value be natural log of x. We simplify, and we're left with 1 over u. The integral of 1 over u is natural log of absolute value of u, which is natural log of x. Plug in the upper and lower bound. Natural log of b minus natural log of 2 gives us infinity, so we know that the series will diverge. So therefore, the only series that converges the first one. Okay, 25. To what number does a sequence converge? So we can just find the limit as n approaches infinity. As it approaches infinity, we see that 5 to the n and 5 to the n will cancel out, 5 will remain, and we have, if we take the highest degree, it's going to be n, so n to the 100 over n to the 100. We'll wipe this out to be just 1, so the only thing that's left over is the 5 in the denominator, so the sequence will converge to 1/5. Okay, so we have our series here, so sine squared x to the k. What's f of 1 equal to? This is in the form of a geometric series. So as long as sine squared of x, sine squared of 1 is less than of 1, and it is, so we know this series will converge because our ratio is less than 1. So f of 1 is simply going to be a sub 1, so if we plug 1 in, we get sine 1 squared divided by 1 minus the ratio, in this case will be sine of 1 squared. So we get 0.708 divided by 1 minus 0.708, which is 2.426. Okay, last page. We have the function f of x, third degree Taylor polynomial about x equals 2 is, so we can, we know our center is at 2, and we can build our Taylor series here, so we can find our way all the way down to the third derivative. So we're starting off with natural log of 3 minus x. Find the derivative, ln of u becomes u prime over u. If we bring this up to the top, we can go through chain rule here. So chain rule derivative, we get 3 minus x to the negative 2 times negative 1. Chain rule again, third derivative would be negative 2, or 2 times 3 minus x to the negative 3 times negative 1. Okay, so then we can plug 2 into each of the derivatives, or each of the values, each of the functions and derivatives. We get 0, negative 1, negative 1, and negative 2. So all this gets plugged into each of the terms here. We know the first two terms is just going to be tangent line equation here. So y minus 1, y minus y sub 1. So there's y sub 1 minus plus the slope times x minus x sub 1. And then from the second term on, we can build our Taylor series here. So second derivative evaluated at 2 is negative 1. So negative 1 gets plugged in here over 2 factorial times x minus 2 squared. And then third derivative evaluated at 2 is negative 2 over 3 factorial x minus 2 cubed. And if we simplify this, we have something that matches answer choice B. 28. Suppose a function is approximated with a fourth degree Taylor polynomial. If the maximum value of the fifth derivative between 1 and 3 is 0.01, then the fifth derivative evaluated at x is less than 0.01, then the maximum error is. So we can go through the remainder theorem. So remainder theorem says the remainder is going to be equal to the n plus first derivative evaluated at z. So we're trying to maximize this value over n plus 1 factorial times x minus c to the n plus 1. Now, we know that the fifth derivative evaluated at x between 1 and 3 has to be less than 0.01. So we know a safe upper bound for this value will be 0.01. So 0.01 will get replaced for the numerator. My n is 4, fourth degree Taylor polynomial, so 4 plus 1, so that's 4. 4 plus 1 is 5 factorial. X stays, well, x is 3, and 1 is the center, so 3 minus 1 to the fifth power. So then we get 0.01 over 5 factorial times 2 to the fifth, and if we simplify this, this will give us 0.00267, answer choice E.